So let us start the next topic, motional electromotive force. Motional electromotive force. Electromotive force here means how the electric current that is to be get produces whenever the coil is to be get movable. So here it is observed that here one of the rectangular coil that we are going to consider here. This rectangular coil that is to be get kept perpendicular to the direction of magnetic field. Here these are the cross that I am going to show here. These cross shows the concept of the magnetic field here, and inside the magnetic field the coil, rectangular coil, in which here the one part of the coil is to be get movable, another part is to be get fixed here. This coil that is to be get kept perpendicular to the direction of magnetic field. You know that here according to the Faraday's law of electromagnetic induction, E is equal to d phi by dt. So here what is magnetic flux? That is B is equal to phi is equal to B into Lx, where L is the length and X is the width here. Actually the formula that comes here, that is from the magnetic induction, that is magnetic flux per unit area, d phi by dA. Okay, so what is area? Area into length. So here the formula is to be it comes from area is nothing but here L into X. So the formula that is to be it comes like this here, that is phi is equal to B L X here. Okay, so is it clear? So you can put this value in the equation of the E. E is equal to d of dt B L X here. So B and L is to be taken outside the derivative here. So you can get E is equal to B L into V L. According to the Lorentz force, here we are getting that F is equal to the cross product of the velocity and the magnetic field here. Whenever the charge that is to be get moving through the coil here inside the magnetic field with velocity say V, there is a cross product of the velocity and magnetic field that is to be get lies here. This cross product that is to be get considered as here F is equal to Q into V cross B here. If you know the cross product rule here, that is A cross B is nothing but here, that is AB sine of theta. AB sine of theta. In similar manner, you can write here that is Q into V cross B. That means V cross B means here we can write here Q into V sine of theta. But here we are going to keep the coil perpendicular to the direction of magnetic field here. So that's why the sine 90 is equal to 1. So we can write here that is the simple formula, that is the F is equal to, that is BQ into V. Simple formula that you can write here, F is equal to BQ. So we want the induced EMF. So what is induced EMF? That is E is equal to work done per unit charge. What is work done? Force multiplied by displacement. L is the length of the coil. So we can put this BQ into L upon Q here. So this QQ will get cancelled. So E is equal to BLV. So these are the formula, that is another formula that is to be get considered here. Whenever the charge that is to be get moving with velocity V here, whatever may be the induced EMF which is to be get produces, that is nothing but here the BLV here. So again there is a cross product that is to be get right here, L into B cross V here. The same formula that is to be get written also like this here. So you can write here that is BLV sine of theta. So this is the equation that you can consider, that is E is equal to BLV sine of theta. Okay, is it clear? Okay, thank you.